So here's our three objectives. I know the decimal place values. I can write numbers as words, and then I can round them with decimals. So decimals, decimals, decimals. That's because we're starting the decimals unit module. So lots of decimals to start out with. And like we're saying, after 6.4 and then the quiz, we'll be able to use calculators. The nice thing about decimal place values, just to start us off with, is we've already looked at place values that were just not the decimal place values. There was a decimal there, we just didn't have to look at it. But now we're going to be looking at decimal or place values to the right of where the decimal would be. And then the rounding idea still remains the same, but it will be important to know where the place values are to the right of the decimal. And then writing stuff as words, which we've done before, but again, it's now got the negative aspect to it, and then also the decimal stuff in there too. So there's decimals, and the stuff that we've covered in the past would have just been this stuff right here. Okay, and again, we don't usually show this decimal. So this line right here, this thick line right here, is representing where the decimal will be. And then, of course, the stuff that we've seen already, ones, tens, hundreds, and then you'd usually put a comma right there to separate the period, and then you'd have 1,000s, 10,000s, 100,000s, and then you can go into the millions if you'd like. But that's what we've covered so far. But today, of course, and in this module, we're adding the decimal, which means we need place values further to the right as well. Now, you'll notice you got ones, tens, and hundreds going to the left. You got ones, tens, and hundreds. Now, because there's ones, you can't have what you would consider onths, because ones and onths would technically be the same thing. But you'll notice you have tens, another place value to the left of the ones. Of course, you have the decimal, and then to the right, you don't have onths, but you go directly into tenths. So this place value to the right here is the tenths place value. Then you'd have hundredths, thousandths, and then so forth. You'll just notice the only difference between these and these ones is the THS at the end. Now, I may emphasize that when we're going over some of the stuff, which is going to sound kind of ridiculous because I'm trying to emphasize the THS. And I'll try to stand far away so that I don't spit on anyone, because that's the way it goes, you know. That's the crucial aspect here, is that the location of where a number is will tell us what the place value is, but it starts with where the decimal is, which is why on these problems we're going to be emphasizing these decimals. We'll try to make them a little bit bigger than what they print as, because the decimal tells us where we change from going from something that's whole into something that is more fractional or decimal type values. All right, here we're going to look at this. We got this big number, and we want to find the digit or number that's in these specific place values. Now, you notice these ones are THS, which means they're to the right of the decimal, but the tens is just the regular old-fashioned tens. I'm going to start with that one. So on this one, we got millions, right? So we're going to, tenths. Let's start with the tenth. Tens, because that's stuff we've seen already. So again, the decimal is important. I'm going to emphasize where that decimal is. I've just kind of made it bigger. And tens are to the left of the decimal because that's where our regular numbers are. To the left would be the 9, which is in the ones place value. And then to the left of that would be the tens. And that is an 8.
This is 6.1.
That is an 8 in the tens place value. Now you notice I didn't make it -8 because it's not asking if it's positive or negative. It's just asking what number is there. And we don't consider that number to be negative because the whole value is considered negative. Okay, so let's go back. We got millions. So let's see if we can do this. So the THS means it's to the right of the decimal. So we got the tenths, hundredths, thousandths, and we'd have 10,000ths, 100,000ths, and then millionths. So that 8, which I've underlined in green, I'm trying to color code this. That green 8 is the 8 that's underlined in green. That's the millions. Now we'll continue from there, and that's millions. So the next one would be 10 millionths, then 100 millionths, and then the last one there, the 7, would be where the billionths are. And of course, just so we understand, because we're going to cover this not necessarily today, but later, is there's actually zeros beyond this. We just can't see them. These are what we would consider phantom zeros. They hold place value, but they don't have any value. Just the same as this 0, and I think that's the 10 millionths place value. It doesn't have any, there are no 10 millionths, which is why we can put a 0 there. And that is the beauty of our number system, because we can put something that represents nothing in there, whereas many civilizations before us did not actually have that as a resource. But that's it. We got millions, billions, and tens. Here's a big number. I'll read it. What the heck? 804,687, and the decimal would be where the and is. We'll talk more about that. 592,213 millionths. Okay, so that's reading that number out loud. I mean, not many people would read it that way, but that's a really nerdy math way to do that. Okay, so we got place values for these digits. We got 9, 7, and 2. Okay, now if you need to refer back to the table that we had before, do it. But just take 30 seconds, see if you can determine what place values these digits are in. Then we'll go over it. Let's start with that 9 right there. The 9 is in the hundred. Now this is careful. We got to be careful on it here, because the 9 is to the right of the decimal. So it's not the hundreds, it's the hundredths. Oh. Now this is where I'm going to go back. I probably kind of skipped this a little bit because I read it, but the decimal, of course, is right here. And then that 9, which is in the hundredths, place values to the right of that decimal. Okay, so what about the 7? So the 7 is one place value to the left of the decimal, so it's a whole value. We'll just fill this in as a ones place value. So the 7 is in the ones place value. Now, this one, it wasn't meant to be tricky. I guess it was just kind of meant to see which 2 that you noticed. But if you notice both, that's fine as well, because there are 2 different 2s. We got this one, which I've underlined in green, and then this other one, which is underlined in orange, right? So we'll do both. We'll start with the green one because it's first to the left. So again, just starting with the decimal, to the right you'd have tenths, then hundredths. Then the first 2 is in the thousandths place value. So we'll fill that in. Thousand, again, it's not thousands, not this, but THS, thousandths, because it's to the right of the decimal. And then the second one would be one more place value to the right, which would then be not the thousandths, but the 10,000ths. Like that. There we go. Okay, now again, if you need to go further, you have 10,000ths, 100,000ths, and then millionths, which, I mean, they could ask you for. You have to type that in, but that's good for now. All right, so writing decimals in words, and again, knowing where that decimal is crucial. Now, we've seen this before, where sometimes what students will do is they'll take every period, so you got like the millionths, the thousandths, and then our base period here. And like we've seen before, what they'll do in writing these, they'll put commas in between the periods like this, okay? Now, in doing that, sometimes people they'll verbally communicate these with ands, the commas, but you can't in a math class. And again, this is just in a math setting like we are in. The only time you use and is when so let me emphasize that decimal.
Why is there no ones on?
So in a math setting like we are in, the only time you use the word and is if there is a decimal. Now this also means that when I correct tests, if I see any ands in place of commas, where I put commas right there, then it's automatic a point off right there. So I'm just saying, don't do it.
Have you seen commas where?
So I'll just make up a number right here, right? Oh, like 1, 2, 3, 4, 5. And we'll just put zeros there. So that this number reads, mathematically, this is formal mathematics. Again, whether you do it in your real life or amongst your friends is completely different. But in math, we would read that 12,345,000. On the other hand, some people would say 12,345,000, which again, in a personal communication, that's fine. But in a math setting, we wouldn't do it. Now, the reason why we don't want to separate the periods there, thousands and millions, with the word and, is because and should only be used for decimal, and as long as we keep it that way, then it's a, in my opinion, it would be a more clear communication of where the decimal is. Now again, whether you do it or not in your personal conversations is completely something different. But everything, so this is stuff we've seen before, but now we're adding a comma in there with an and. After this, what we're going to do is we're going to ignore any digits or the place values of any numbers to the right here. So what we would do, let's see if I can put this into words adequately. So we write the number as though it were not a decimal. But the number, the place value, that's what we'll say. The place value furthest to the right. Let's see how I want to word this. The place value furthest to the right is how we end the number. It seems decent to me. Okay, so we'll look at some examples of this. That may not make sense right now. But just understand, whatever is to the right of the decimal, we treat it as though it were not a decimal. And so we just kind of speak it as though we're just a regular number. And then we say, we just finish off that number with the place value of the number furthest to the right. Now zeros, just like we would with the regular whole values, we don't necessarily count those. So, for example, if there was like, if I had these zeros here in the tenths and hundredths, I wouldn't say, well, 0, tenths, 0, hundredths kind of thing. So if I saw something like this, so let me write this as a regular decimal, 0.0054. And again, we're going to see more examples like this. I don't care about the tenths. I don't care about the hundredths. I don't even care about the thousandths here. The only place value I care about is the 10,000ths. But I speak this number, not the zeros, just the numbers, the non-zero numbers, as though they were just a regular number. That's 54. So I'd say that's 54, and then I declare the place value furthest to the right, which is the 10,000ths. This reads 54 10,000ths. All right, so this is a number which we need to put into words. Now, of course, we would usually just say probably, even in a science setting, they'd probably say something like 0.068. And that's fair. But this is a math setting, so we have to actually speak it and communicate it in words, which we're going to write out. Yeah, so we look at this one, and we say, again, I don't care about the zeros. Now, if there was something in front of the zeros, I might care about them, but I don't care about them the way they are. I just say this one is 60, and then I'll make sure you hyphenate these, because math nerds don't like it when you don't hyphenate, which is kind of weird because it's kind of an English thing, you know what I'm saying? 68, but this is to the right of the decimal, so all I got to do is figure out the place value that's furthest to the right. So we got the decimal, that's where the decimal starts. You got the tenths, hundredths, and then the 8 is in the thousandths place value. So we're going to take that 68, and we're going to say that is 68 of the thousandths, with the THS at the end, indicating that is a decimal value. Now again, this one does have a decimal. We didn't need to put the and in there. We wouldn't say this is 0 and a 68 thousandths, because there's no whole values in the number. So we just say 68 thousandths, boom, that's it. One of the major problems on an exam is this. right there, okay? Because it's, they understand that it's the thousands place value, but don't forget the THS at the end. All right, try this one. See if you can write this one in words. Okay, now, again, if you need to use this chart right here to kind of line things up, then feel free to do it. In fact, I'll just write it out down there below just so we can kind of see it, right? So that we got the decimal right there. It's a negatives, right? That looks kind of like a 6. And then we got 0, 9, 8 right there, okay? So if you need the chart to line things up, then feel free to do that. Now, of course, the thing that we didn't see when we went over this type of stuff before was the negative. We did not see negatives. This time, this number is negative, and that's the first thing we need to declare is the sign if it's showing the negative. Negative. Okay, so that's our start. We know it's negative. Now, of course, the last example that we did was positive, but we didn't have to declare it to be positive. So positives, we don't say it's positive something. Don't put the positive in there. But the negatives we definitely need. So it's negative. Then I would look at these numbers. Okay, that's a 5 in the tens, 0 in the ones. So that should be 50. And again, we should have seen that already. 50, 50. There we go. Then I run into that decimal. So I'm going to put in the word, I'm going to emphasize that decimal. You don't have to, but I'm going to. So all caps for and. Now I look at the rest of the numbers there. Okay, the rest of those numbers, I see a 0 in the tenths, a 9 in the hundredths, and then an 8 in the thousandths. So again, I don't care about the 0. I'm pretty much looking at this number right here, right? We've already taken care of the negative and the 50. But now I'm looking at this number, which means I don't really need that 0 right there. And I would read that number as it is, again, without the decimal first. That would read as 98. So the 90, there we go. 98, and I've hyphenated that. Okay, so since we're in the decimals, though, we need the place value specifically of the number furthest to the right. So we look down here. It's an 8, which is in the thousandths place value. We'll take that as 98,000, again, not thousands, but thousand. I'll emphasize that THS right there, thousandths. And that's how we would read that number, negative 50 and 98 thousandths. Okay, now we're going to take a number, this number. So this one now is written in words. We're going to do this backwards, right? So it's written in words for us. What we need to do is write the actual number in digits. So first off, we'll start here. It says that it's negative, so I'm going to write my negative out. In fact, I'll use the chart down here. It's a negative, so I'm going to put my negative in first. Okay? Now, it'll be important to notice where the and is. Okay, because that's where our decimal is. So the and, which is where the decimal is if I can get this technology to work, it's going to be right there. Okay, so to the left of the and is the whole value. And it says it's 96, so that'd be 9 tenths, 6 ones, 96. Now I've separated the negative. I'm going to rewrite this afterwards. Next, it says there's going to be 21 in the hundredths place value. So where's my hundredths? Hundredths is right here. But I need to show that there's 21 of those. So you can kind of work backwards from here. It'd be 1 and then 2. That'd be 21 right there. That's the number that we want. It would be negative 96 and is the decimal 21 hundredths. Now be careful because if this, let's theoretically say that this was thousandths instead. Then the 1 would have to be here in the thousandths, the 2 in the hundredths, and then anything else to the left of that between there and the decimal would have to be zeros, which I think we're going to see an example of, okay? This is the answer we're looking for. Okay, try this one out. Negative 46 thousandths, and we'll go over it. All right, well, first off, it does say that it's going to be negative, so I'm going to put in my negative. And this one goes straight into a number that's got the THS at the end. So we're looking at decimals here. Now I'm going to put this 0 in here just to show that there are no whole values, but technically you don't necessarily need to do it as long as you emphasize the decimal, okay? Next up, it says that there's 46 of these thousandths, okay? So in the thousandths place value, which is here, I need 46 of those, so that'd be 6 and 4, 46. But then I've got an empty place value with the tenths, and that's where we fill that in with a 0. Okay, so this ends up being negative 0. There's our decimal, 0.046. Negative 0.046. That would also read as negative 46 thousandths. All right, write the decimal approximations for the given numbers as place value numbers. Okay. So what they've done is they've given us a number that is not in what we can call standard form, just the regular way that we write a number. It says that the population of a town was approximately 10.12 million people. That's 10 and 12 hundredths of million people. That doesn't seem right. We'll just say 10.12 million people. That sounds better. Okay, so here's the thing, and this is going to work the same way when we get into the decimal numbers as well. The first thing I notice is that it's giving me 10 million people, okay? So that means I've got to go to the 10 millions, not millionths, but million place value. That's what it says, million, not millions. So the 10 millionths that would be 10 million right there. Now it says 0.12, so technically the decimal would be right there, which I put in blue. That's decimal. And then you'd have the 1, 2 like this. Now, of course, the actual decimal for our standard form number is going to be over here. So I don't want that blue one right there. I don't want it. But what I'm going to do is I'm going to fill in all my empty place values between the 2 and the 10,000s. I said thousand. 10,000s place value in the decimal. Now again, this is where we go back and we say every 3 place values. Some students like to put commas, although it's not required that you do so. But this would be the same as 10,120,000 people in this town, whatever town it is. And even writing it like this, we don't necessarily need that decimal either, but I don't mind it being there since we're in a decimal unit, just to remind ourselves that it goes there. And that would be 12.12 million people. Now you'll notice I did not put a label on this because we didn't need to. It was just asking for a decimal approximation. And that should work. If you want to put people on there, that's okay too. Okay, same thing on this one. The width of a piece of paper is approximately 8.95 tenths of an inch. Try this one out. See if you can write the decimal value for that. So this one says 8.95 tenths. I don't really care about the 0.95, but what I see is 8 tenths to start. And then we can take the portion of that as we need. So 8 tenths, there's my tenths. So I would have 8 of those. Okay, now again, the decimal is this line right here. So I've just brought the decimal down there. And since there are no ones or holes in this, then we can put the 0 there if we want. But it's not necessary that you do. Okay, but I've got my 8 tenths, but then there's the portion of the tenths as well, the 95 hundredths of tenths. So that'd be 95 just after that. And again, this would be 8.95 of the tenths. But the way this number reads for us, and again, this is in inches, but this is 895 thousandths if we were to need to write that number on our own. That's the decimal. I guess it's not really approximation. It's just the decimal value of the value that was given. And you can see how this can be kind of confusing, right? You can say 8.95 tenths. You could say 8.95 millionths or something like that. It's kind of jacked up if you do it that way because it can be like a double place value kind of thing. But it's doable if you have a nice chart in front of you like this. Okay, decimals as base tens. Now, a base, which we talk about in the exponents unit, or whenever we talk about exponents, you have a base and then you got an exponent. So if you were to look at this, just this number right here, that's 10 to the power of 7. 7 is the exponent, 10 is the base. Or this one would be 10 base to an exponent of 4. But you'll see what happens is, as we go down the line for our place values, 10 to the right specifically, and of course our decimal would be right here. Yeah, there it is. Okay, so that's where our decimal is. But you see what happens is we go to the right here. The exponent goes down by 1. Now, 10 to the power of 0 is 1. Don't worry about why that is. You'll go over that in some other class. But 10 to the power of negative 1, what we end up with is we go to the right of the decimal is negative exponent. So 10 to the power of negative 1, negative 2, negative 3, and negative 4, and so forth. So we can show the whole chart now. It's better. The good news for us is you don't have to worry about the exponent stuff, but it may help us in understanding what they mean by base 10. Okay, so all of these values, whole values, are over 1. This would be 10 to the power of 7 over 1, 10 to the power of 3 over 1. But once we get into negatives, it becomes 1 over this, which is why we end up with 1 over 10, right? So this was just 10, 100, 1,000, 10,000. Now it's 1 over 10, 1 over 100, 1 over 1,000. 1 over 10,000, and so forth, okay? Which we're going to need to know when we get into the assignment, because they're going to give us a number, and then we've got to rewrite the number in this format with the fractional stuff. That may not make sense right now, but let's look at this example. So they give us this number, negative 372 thousandths. Okay, there's no and in here, so there's no ones, which is why they're showing the negative for us, okay? So 372 in the thousandths, and the thousandths place value is this one right here. 1 over 1,000 would be 1 1,000th. Okay, well, how many of those are there? Well, it says that there's 372 of them. So you'd have the 2, 7, and then the 3. And that would do fine for this part that says, write it in place value form. Okay, this is negative 372 thousandths. So we've seen that already a little bit. That kind of goes over what we've already seen. But now it wants it written in base 10 expanded form right here. Okay. So expanded form, just so we remember, is where you take each place value and add them together. So in the past, you probably took like 7 million plus 300,000 plus 50,000 plus, I don't know, 720. I don't know, 700 plus 20, something like that. But now we're going to do it with fractional values or decimal values like we have right here. Now, again, there's no whole values on here, and that's okay. I'm going to put my negative out here in the front. But what I notice is that I've got a 3 in that'd be the 10th place value right here. Okay? I need that space. So the 3, first of all, is in the 10th place value, so we'll make that 3 of the tenths. Then we've got 7 in the 100th place value, so that'd be 7 of the hundredths. And then finally the 2, which is in the thousandths place value like this. Okay, now that's not finished. What we're going to do, since it's negative, I'm assuming they want minus signs on here. Yeah, I mean, if you really wanted to be clever, you could put parentheses around it with plus signs. The negative's kind of throwing me off, but either way. Okay, so I'm going to take it back to what I had before. Now, usually in the past, what we would have done is just shown plus signs, but the negative is going to make that a little bit more jacked up for us. So if this were a positive, then you'd keep the negative off, then you just put plus signs in between. But since it's negative, we got to subtract all those from each other, which would then give us negative 372 thousandths. Again, 372 thousandths. Boom. Okay, decimals on number lines. In the past, we've seen number lines like this, and you'll notice there's There's 9 marks between the 0 and -1. That's because -1 would be the 10th mark, or you count 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 10th mark, so this is cut up into tenths. The problem with the number lines you're going to see now, because we're looking at decimal and fractional type values, is what they're going to do is, like, this is -1/10, but it's cut up into 10 parts, which means this is a hundredth. This would be 2 hundredths, 3 hundredths, 4 hundredths, and then all the way to 10 hundredths, which is the same as 1/10, or negative in this case. So when we look at these with decimal values, you just got to be careful, because you got to look. They generally are split up into 10 parts, which means that, let me see if I can fix this up for decimals here. Okay, so instead of this being -1/10, this one right here, what they'll do is they'll say this is -0.1, and this one would be positive 0.1, like this. Okay, which means that this would be, for example, this would be -0.01, -0.02, -0.03, all the way until you get to what we would really show as -0.10, or 10 hundredths. And the same is true to the positive side. If you need to see that with an extra 0, then feel free to do that, because that may be helpful for you in understanding what is going on here. That'd be 0.01, 1 hundredths, 2 hundredths, 3 hundredths, 4 hundredths, 5 hundredths, 6 hundredths, 7 hundredths, 8 hundredths, 9 hundredths, 10. That's what that would read right there, 10 hundredths, even though by itself it's only one individual tenth. Now, they're not all going to work this way, which is, again, why you have to pay close attention to the values that they give you on the number line, so that you don't get them mixed up with this basic number line like we've seen in the past.
Okay.
When we're dealing with decimals, what you're going to want to, well, you probably will want to see the 0 right there, which hopefully will help you to understand what you're dealing with in terms of these decimals right here. Okay, so let me put this first number on there for you, and let's see if that helps. Okay, so first off, I notice this is not 0 right in the middle, it's 6. Now, if you go 10 marks to the left, that's 5.9, or, again, if you need to see that as 5.90, then feel free to put that in there. That may be helpful. Same over here to the right, if you want to see that as 6.10, and even if you wanted to show 6 as 6.00, that, again, it just may be helpful. I don't know if it is going to be helpful, but I hope it would be. The first number that it wants, which I'm going to do in red, I'll try to color code these, is 6.09. Okay, so that's 6.00. Here's 6.10. And there's 10 marks well, not in between, but there's 10 marks here to get to the 1 unit, which is a tenth of a unit. So you could even count from 6.00, 6.01, 6.02, 6.03, 6.04, 6.05, 6.06, 6.07, 6.08. I kind of skipped one there, but 6.09 is that red mark. Again, you'll put a dot right there. I've just kind of marked it extra. But that would be where 6.09 is. Now, again, if you look at this as just 6.1, it may get kind of confusing, because students, this happens all the time on exams as well, where students are like, that's 6.1, 6.2. No, these are tenths of tenths, which makes these hundredths, and this is 9 of the hundredths, 6 and 9 hundredths. There's the 6 and then the 9 hundredths. Boom. So 5.92, come back here to 5.9. We put the 0 there. So this next one will be 5.91, and then the final one there, the next one rather, this one right here would be 5.9, but 2 extra marks to the right there. So again, that should be a point that we put on the line. Now again, I'm trying to color code these. So 6.03 I've gotten green. So 6.00, 6.01, 6.02, and then finally, this mark would be 6.03. Boom. Okay, so again, we just need to be careful, because, again, some students like this, 5.90, 6.0, 6.1. No, this is, it goes from 5.9, and then after 10 marks, you get to 6. After 10 marks, you get to 6.1. So each of these would be hundredths, not tenths. Okay, rounding. So this one, I don't usually do this with the rhyming stuff, but if you go on YouTube, you can find this and it's sung and it's hip. Good thing I'm old because I'm not hip anymore, so I'm not going to sing this for you guys, but I know you wish I could or would. I'm just not going to. So underline the digit, look next door. If it's 5 or higher, add one more. If it's 4 or lower, just ignore. That's about as close as singing you're going to get out of me right here. But this is fair enough, okay? So you look at it says underline the digit. They'll tell you, that's the target place value. I like to call it target place value because they'll say, look at this place value, round to this specific place value. So that's, when it says underline the digit, that's the, again, I'll say target place value. But it's the place value they say you need to round to. That's all, okay? Now it says look next door as well. When it says next door, that's to the right, one place value. And if that number is 5 or higher, then you add 1 to the underlined or the target place value. If it's 4 or lower, you just ignore it, and then you keep that the same. Now, we've done rounding before in this class, whether it was from last semester or this one, I can't remember, but still, we've done it before. So we've done this before with whole values, but now we're doing it with place values. So they're just going to say round to the nearest place value instead. Okay. We shouldn't see front-end rounding necessarily with place values, so that kind of takes away one of our types of rounding. This is round to the nearest 10,000th place value. So let's identify where that is. Okay, so we got the decimal. I'm going to emphasize the decimal again. We've got tenths, hundredths, thousandths, 10,000. So that's the 4. Get rid of this other red here. Okay, so that 4, I've underlined it. I look next door, which means it's to the right. And I like to circle it. Yeah, now that 2 that I've circled is less than 5, right? So the 4 in this case it's just going to stay a 4. Now everything to the right goes away. All this stuff here, we don't need to drop any of these place values like we would with regular rounding or whole value rounding. Now the 4, since it stayed the same, everything to the left though stays the same as well. So we got 0.6924. We'll read that. That's 6,924 10,000ths. And that has been rounded. Okay, so again, we didn't care about this 2. This number could have been 7, it could have been 9, it doesn't matter. There could have been other numbers to the right of it. It wouldn't have mattered. The only value we look to when rounding is the number to the right of our target place value, which in this case is the 10,000ths place value. Okay, try this one. Round this one to the nearest hundredth. Take a minute, try it out, then we'll go over it. All right, this one says around the nearest hundredth, so let's find our hundredth, right? We got the decimal. Hundredth means to the right of the decimal, so there's tenths, hundredths. I found my hundredths, that extra mark there. So I like to circle the number to the right of it, which is a 9. A 9 is 5 or more. So to my target place value, which is underlined, I'm going to have to add 1 right there. And I'm going to put a line right here, just like I was adding a regular number. And you'll see what I end up with is 9 plus 1 is 0. That's in my hundredths place value. Now, even when you're adding with decimals, which we will get into later on this module, the decimal will not move. So I'm bringing the decimal down because I see that 9 plus 1 is 10, which means I need to carry into the next place value to the left, just like I would with regular addition. Now, the 9 and 1 there also make an extra 10. So I carry that 1 over into the ones, right? So this is how this works. You got 9 plus the 1, which was like 10 hundredths, which is the same as 1/10. We had 1 and 9/10, which is 10 tenths, which is the same as 1 whole. And now I've got 1 and a 5, which would make 6 for my ones place value. And then there is no more carrying necessary here, but all these other values need to drop as well. So the original number was 7,265 and 9,991 10,000ths. But we rounded to the nearest hundredth, which made that value 7,266. Now, is that always going to happen? It will not, but be aware, if you have nines, like we do here, and I put those there on purpose because they're going to do it on the assignment, you may have to do some carrying like I did with these values here. But again, always make sure that you just drop where the decimal is and then keep everything else aligned just like you would with regular addition and place values. All right, there's our three objectives. I know the decimal place values. I can write numbers as words, and I can round with decimals. We did all three. Hopefully it was adequate enough to get that assignment done.